Hi there, my name is Mark, and this is Pacific Northwest Solar. Our family has a solar array installed at our property in rural western Washington state, on the west coast of the United States. I've been inspired by other YouTubers to share my experience with our solar array, and how it impacts my power costs. This video details my results for February of 2024, and I hope it will be useful information if you are considering getting solar at your home. Please also see the link to my separate video that gives more details on our installation, listed below in the description. This year I've added some additional content which I hope you will think is useful. Here's a picture of our 16 kilowatt ground mount solar array. The solar array is directly south facing in one of our pastures with no trees or other obstructions around it. We have 50 Z and Shine panels, rated for 320 watts each, with Hoymiles M300 micro-inverters on the backs of the panels. These micro-inverters convert the panel's DC output to 240-volt AC power, which is sent back to the breaker panel at the house. There is only one choice of electricity providers where we live. Currently, the cost of electricity from the grid is the same no matter what day or time it's consumed. No time of use rates. Any power generated automatically goes to usage in the house first, and then any additional is automatically returned to the grid. We get a 1-to-1 credit for each kilowatt hour that we send back to the grid. These credits directly deduct from the power we are charged at the end of the month. As you can imagine, the overall idea is to overproduce in the summer and use the credits to reduce or eliminate the electricity bill in late fall and winter months. I am using a Sense device in my electric panel to track power generated and power consumed, and I have written a custom Python program to capture real-time metrics for the entire system that I save and analyze. This is what the Sense app looks like, showing the statistics for the month, including solar production, usage, energy to the grid, and energy from the grid. February is still in winter, solar production is growing, but is still not close to meeting the usage demand. The fully blended cost for electricity in this month, including all taxes, fees, credits, would be 13.1 cents per kilowatt hour, which is about 9.5 pence per kilowatt hour for my UK viewers. Using this rate, the value of the solar production for this month was $107.67. The cost of my usage would have been $183.81 at this blended rate if I didn't have solar. Here's an overall look at the solar production for February 2024 by day. Total production for the month was 822.7 kilowatt hours, with the lowest day being 5.8 kilowatt hours on February 25th, and the highest being 79.4 kilowatt hours on February 23rd. The total monthly production was about double what it was in January. The overall average production per day was 28.4 kilowatt hours, which is nearly double the January average daily production. The total amount of hours of sunlight per day went from 9.5 hours at the start of the month to 11 hours at the end of the month, which greatly increases solar production. Also, February 2024 was a leap year, so there was one more day of solar production included in the totals. Here's a comparison of the February 2022, 2023, and 2024 solar production. Since we now have 3 years of data to look at, it can be interesting to look for patterns. Nothing really sticks out as being especially significant this month, since there are always natural variations in the weather. As a way of comparison, the PVGIS website suggests that I should get 1,120 kilowatt hours at my location during this month. The weather was quite cloudy for most of the month. Here's some additional details for the highest solar production day, February 23, 2024. At my location, the sunrise was at 7:01 a.m. and sunset was at 5:43 p.m. for a total of 10.7 hours of daylight on this day. Highest 1-minute sampled solar production was 12.0 kilowatts at 12:56 p.m. Here is solar production and actual usage, plotted together for the highest solar generation day of the month. The morning high spike on the usage graph is from the electric furnace turning on. The furnace was on for about 20 minutes total, consuming 5 kilowatt hours of electricity by itself. The high usage from 4:30 p.m. to 5:30 p.m. was cooking dinner and running the dishwasher. It's also interesting to see the consistent higher level of usage from about 6:30 a.m. to about 11:30 a.m., which was my space heater that I used to heat my office in the mornings. By lunchtime, the temperature was warm enough that I didn't need the heater on anymore. Low temperature of the day was 33 degrees Fahrenheit, 1 degree Celsius, and the high was 53 degrees Fahrenheit, 11 Celsius. Here is solar production, overall usage, energy sent to the grid, and energy from the grid on a per-day basis for the month. Usage in this case is power used by the house, regardless of whether it came from the solar panels or not. The two large to grid spikes were on days with high solar production. From grid dominates the graph, as you would expect for this time of year, and since I don't have a home battery system. Here is the month-by-month comparison of the actual amount that I paid the power utility each month for 2022 through 2024. All my accumulated credits with the power company were exhausted this month, so I ended up paying $150 for electricity. This is still significantly lower than in the past years, however. Here is the month-by-month comparison of solar production between 2022, 2023 and 2024, along with the yearly total solar production. Year to date, 2024 is running behind as compared with 2023 and 2022. We'll see how we are doing overall after March's data comes in. Here is the month-by-month comparison of our usage between 2022, 2023 and 2024, along with the yearly total usage. I have very little control over the solar production, but I have a lot of control over how much power is used. You can see that total electricity usage is down about 1/3 to 1/2 as compared to the previous years, so the changes I have made definitely are showing. Thanks for watching. Please give this video a thumbs up so other people will be able to view this video. If you have any other statistics that you would like to see, please leave a comment down below. Have a great solar day and see you next month.